Large language models can actually do some planning, which is an interesting ability. So they can actually go through and take patterns and with few-shot examples, and they can learn what the next action should be, given a particular situation. But I'm giving you this example not because they're limited to, coming up with planning in the sense of actions or, doing sentiment analysis, but I want you to expand your sort of mind on what's possible with few-shot prompting and see it as a technique that can be taken and adapted to all kinds of situations. So we've seen how we can use few-shot prompting. We're doing sentiment analysis. Now we're going to do something very different with it. So we're going to take a look at this example where we're describing different situations with driving a car. So in the first one we say, situation, I am traveling 60 miles per hour and I see the brake lights on the car in front of me come on, and the action is, we're going to brake. So again, we've got a first example in our few-shot examples. Situation, I've just entered the highway from an on-ramp and I'm traveling 30 miles per hour. Action, accelerate. So we're teaching the large language model that it's going to be given a situation and it needs to decide what the car should do. Situation, a deer has darted out in front of my car while I'm traveling 15 miles per hour and the road has a large shoulder. Action, brake and swerve into the shoulder. Situation, I'm backing out of a parking spot and I see the reverse lights illuminate on the car behind me. And then we prompt it with action. We leave off at the end of our prompt with something that indicates to the large language model we want it to decide what the action is. And what do we see it do? It actually says, stop and wait for the car to back out before proceeding. And it's making a sensible, decision about what the action should be. Now, I don't think we should go and build self-driving cars with few-shot prompting. I don't think we're going to get there with that. But I do want to show you that we don't have to think just with a narrow, rigid box of classify something. We can actually kind of have complex tasks that we're having it perform. Now, sentiment analysis is a complex task, but this is also a very complex task that's sort of in a different vein. So I want us to think very creatively about how we can use few-shot prompts. Now, again, one of the things that we're getting some constraints on our output. It's learning what the output should look like. Now I'm going to then go and do something else interesting. I'm going to show you kind of an interesting capability of large language models. And one of the things that can be done to use one large language model to teach another one, which is kind of an interesting capability. So I'm going to say, please provide more examples. And then I'm going to kind of prompt it with situation. And it's going to start generating additional situations and actions. So it's learned from our pattern the types of things that we're describing and the types of actions, and now it's going to go and generate more examples. So it says, you are driving in heavy rain and notice that the road ahead is flooded. So this is the continuation of our situation. And then it says, action, slow down and cautiously drive through the flooded area, watching out for other vehicles and avoiding sudden movements or changes in direction. I would actually disagree with this. I'm not sure that it's smart to drive through a flooded area. That's probably questionable decision-making, which again, just reminds you that you need to own the output of the large language model and check it. Situation, you are driving on a 2-lane road, and a car is approaching you from the opposite direction with their high beams on. Action, dim your headlights to low beams to avoid blinding the oncoming driver. But you notice the interesting thing about this is it's giving us some rich situations and possibly appropriate actions. I'm not sure I agree with the flooded one, but we're generating different examples of situations and what to do, and they look very similar to what we produced before. And one thing that's interesting is we can actually take examples like this and then curate them and have a human edit them and then provide them back to a large language model either later as additional examples for our few-shot examples. And so once we've had a human look at them and curate them a little bit, maybe clean them up, maybe we don't want that one on flooding because we don't think that's a good idea. So we actually say, well, you shouldn't drive across flooding, or we sort of spell out the rules. But you can imagine that the level of effort to create the initial examples right here is much higher than the effort to go through and generate subsequent examples, which we can then go and hand edit and curate. So we can quickly build up these examples, both in order to generate an output right now that we want, but also to generate examples that we can later give back to the same large language model or that we could go and give to another large language model to teach it. And in fact, some people have actually gone and done this. They've taken output from ChatGPT, for example, and they've taken it into another large language model like Facebook's LLM and used the output from ChatGPT to improve the outputs of LLM. And so this is another interesting capability, is that large language models, through these few-shot examples, they can generate few-shot examples for other models. The other thing I just want to go back to is this is a very different sort of task and style than we had before. We have a situation and then we have an action that's being predicted. And so we can have all kinds of interesting things. Anywhere where we can have a pattern that we can describe, a set of examples that show the input and what we want the outcome to be. And we can also show things that have intermediate steps, which we'll look at in another video. Let's talk intuitively about what a pattern, what a prompt is doing, and how the patterns in the prompts sort of tap into the capabilities of the large language model. I think looking at some examples will help to give you a sense of how your prompts are really affecting and eliciting different behaviors from the underlying large language model that you're interacting with. So, let's take a look at this example. I want to start off by talking about pattern. Pattern's really important. Remember, as we talked about, large language models are trained to basically predict the next word. They're constantly trying to predict the next word based on what came before. So you give it a sentence, and it's trying to predict the next word, and then it's taking that and adding it and trying to predict the next word and over and over and over. And so it was trained on large pieces of the internet trying to predict the next sentence. So one of the things that it's learning to do is to recognize patterns that tell it what the next word should be. That's basically what it's doing. Now, this is a really simple example of this concept. I'm going to tell ChatGPT, complete this story, and I start with, Mary had a little, and I stop. Now, if you know the nursery rhyme, it's, Mary had a little lamb. Its fleece was white as snow. And you can imagine that this story showed up over and over and over and over in the data that ChatGPT was trained on. So when I say, Mary had a little, that is a very powerful pattern that ChatGPT has seen many, many, many times. And so it immediately tries to pick up with, lamb, its fleece as white as snow, and everywhere that Mary went, the lamb was sure to go. So that pattern was seen so many times that ChatGPT, when I put in the first part of it, it immediately responds with the next part of the sentence. It knows where to pick up. So one thing we have to think about is if we know the right patterns, if we can tap into things that the model has been trained on and seen over and over and over again, we'll be more likely to not only get a consistent response, so we're going to consistently get a particular completion of Mary had a little, because it's been seen so many times in the training data, we get more consistency, but we're also going to more likely get a particular sort of ability to tap into it, to unlock it. Like if we want a particular behavior, we would have the right pattern that we're tapping into. Now, let's look at what happens if we change the pattern a bit. And so I say, rather than, Mary had a little, I say, complete this story. A girl named Mary had a microscopic. Now, this isn't the pattern that it was trained on anymore, right? And it says, a girl named Mary had a microscopic friend named Max. Max was so small, you could only see him through a microscope. Despite his size, he had a big personality and was always eager to go on adventures with Mary. One day, Mary decided to take Max on a trip to the local pond. She carefully placed him on a lily pad. Now, one of the interesting things is you can imagine that when you start talking about microscopic, that you can think about there's probably descriptions of going to a pea pond and doing, science with a class of students. I mean, I almost have a vision of it reading stories about, students getting samples of pond water and looking at them under a microscope. But the important thing is you notice that Mary had a little, created a very, very specific response, whereas a girl named Mary had a microscopic creates a much different response. And then if we go and rerun this, we get something completely different. Pet named Max. Max was a tiny creature that lived in a small G jar. And so, this pattern isn't strong. There are words in this pattern that are strong and sort of give context that help to shape the story. But the pattern itself is not as strong as Mary had a little. So doing it again, whereas the other story changed completely, I'm still getting the same completion with this. I'm still getting lamb. Its fleece was as white as snow. So every time I'm getting a very consistent, you know, response to this pattern. So one of the things to think about when you're writing a pattern or writing a prompt is what patterns do I have in my prompt? And what patterns will will that probably tap into that the large language model was trained on? So now if there's a very strong pattern in the prompt, you're more likely to get a response to that pattern. On the other hand, if that's not a pattern that it was trained on, it's not as clear, then you're going to have other things that are going to matter, like specific words. So microscopic is going to fundamentally, that word is fundamentally going to change the behavior of this prompt because it's such uh, a strong word. A girl named Mary is sort of generic. There were probably lots of stories with a girl named Mary, but microscopic, it has all of this feeling and implications to it, and that's going to then influence the large language model's output. Specific words alone, because of the patterns around those words, like microscopic is always going to be talked about in the context of small things, probably, or maybe in terms of things like in this case, like a small creature that lived in a glass jar. You know, that that word itself has a strong sort of pattern of other words that are coming around it, but it's not as strong as the pattern Mary had a little. Now, one thing to note is that when you're writing prompts, you want to be really specific, or you want to provide enough detail in your words that the large language not model will know the right level of detail to put into the output. So if your words are very generic and high level, then you're more likely to get an output that is also generic and high level. So if you look at this example, I say, discuss Vanderbilt University, and I get a very generic sort of response. It's a private research university located in Nashville, Tennessee, founded in 1873 by Cornelius Vanderbilt. Ranking, other things. Now, if I want something really specific, I need to make sure that ChatGPT has the right words and context in order to answer my question. So ChatGPT is not a mind reader. You have to give it the context. You have to give it the words that are going to elicit the right response. If I go back and I say, discuss Vanderbilt University with respect to Kirkland Hall, it's a specific building on campus, then it changes the output, and I get a much more specific output. I get Vanderbilt University, private research university located in Nashville, Tennessee. Now, we notice we're getting this fairly consistently, both of them, so that's probably pattern that, or information that the model was trained on and saw over and over again on different web pages for Vanderbilt and different documents. And then it cues in on the Kirkland Hall, and it starts discussing, Kirkland Hall is one of the most iconic Val buildings on Vanderbilt University campus, named after James H. Kirkland. It then talks about Kirkland Hall, Kirkland Hall, Kirkland Hall, and so we've now completely changed the output. Now, even though we had shared a common beginning, we got a much more targeted output. And the key to this is that we added in specificity into our prompt about what we wanted, the details. So if you think about asking it to write something or to analyze something, it's always helpful when you say, with respect to, and give it very specific words or names or things that you want it to then use to trigger the output. Because what we see is this Kirkland Hall is a very powerful word that then gets woven into the whole discussion. It's a powerful, name of a building. If we just say generically at a high level, we don't use specific words, we don't use a specific context, we're going to get very generic stuff. And this is probably stuff that if you go and look at, descriptions on Wikipedia, descriptions on Vanderbilt's web pages, this is like the most common types of information that you see. So in order to break out of the mold of what is common, you need to inject the more specific ideas that you want in the output, or you need to inject patterns that will help tap into those more specific things. So this is an important aspect in that if you just use it and you ask it generic questions, you're going to get generic answers. If you ask it average questions and average things, you will get average answers. To really use it powerfully, you have to use your own creativity and thought to get specific about details, aspects of what you want discussed, and think about what are the right patterns to put into your prompt in order to trigger the behavior that you want. Like we saw in this Mary had a little lamb, or we might want to do the opposite. we might know that we're going to get a very generic response because certain things have been seen a lot. And so we need to come up with tricks or patterns or specific words that will help break us out of those patterns that we're seeing in the training data so that we can get something that's more of what we want. So we don't want to be trapped into the completion of Mary Had a Little Lamb. So we go and add specific words like microscopic and a girl named Mary so that it's not so strong, so that we're not directly getting to that pattern. So just changing the wording can help us escape the patterns or get into the patterns, depending on what we want. And then when we get output, the more generic our language, typically, the more generic the output. The more specific our language, the more specific the output. And if we want certain things in that output, we need to make sure we have specific words and phrases that will tap into the specific things that we want in the output. Now, one of the other things is we're talking about output, but in the sense of a query. Like if I have specific words, it'll pull in the right information. One of the things we can also do is our prompt itself is a pattern that the large language model is learning from, and it can also tailor the output. So as we've seen in examples before, we can go in and do different things to try to affect the output. So for example, I might go in and actually, let's change this up a little bit. Let's say title, and we could say title of article, and then we could say author, and then we could say summary, and we could go in and give it something that it can look at and respond to. So now what I've done is I've gone and provided it some structure. Now it hasn't followed my structure exactly, and this is actually a failing in my prompt. It hasn't quite thought of the right structure, but I've gotten pretty close. So I went and influenced the output and the structure of the output by giving it additional pattern in my prompt itself. So one thing we can do is we can tap into patterns in order to influence the output. Another thing we can do is we can go in and use specific words and phrases to kind of be a query across or CL, or to basically collect learned information that's inside of the trained model. Another thing we can do is we can go in and we can provide information or basically new pattern that then influences the output. So in this case, I provided the structure of what I wanted, and it somewhat followed it, and I could probably go and rerun this thing and get something a little better, and in this case, I do. So this will be another thing that we can do is we can use our prompt to create sort of new patterns that it's trying to follow in the output. So the prompt itself can introduce new patterns or tap into them in some respects. So this is kind of creating pattern that it then is responding to as well. So when you're writing prompts, it's really important to think through this concept that it's trying to predict the next word, and it's doing that based on patterns it's learned in the past, and patterns that are in the language of our prompt, and patterns that are based on the word choice that we have, patterns that are based on the sort of organization, the sort of textual organization. And so those patterns can help us get a consistent response. If we have a really strong pattern that always produces a particular next token or next word, then we can rely on that. If we don't want that behavior, we can try to change our phrasing or words so we get out of that trap. If we want to make sure certain information is pulled in, we need to create specific words or patterns that are more likely to have been seen in the context of that information that we want. If we want more generic information, then we probably need to give it more generic language or tell it that we want it to be more generic in some respect. And then finally, if we want the output to look a certain way, we need to give it sort of a sense of pattern in the output. We need to tell it about the structure. We need to give it words and patterns in our prompt that will be likely to influence the output. So you can imagine seeing title and author on an article was something that was fairly common. So if I put title and author in this way into my prompt, then it's more likely going to want to go and create title and author again and sort of replicating the pattern of what I'm showing here. So that should give you some intuition about how all of this works and some things to think about when you're going and structuring your prompts, picking words for them, picking the patterns in your language, and picking the things that you want to go into the output, how you structure and kind of explain the output to it. A really critical thing to understand is that a prompt is fundamentally the input that we have into the model, and we have a limitation on the size of the prompt that we can create. So we can't go and create a prompt of unlimited size. Every single large language model is going to have some fundamental limit on how much we can put into our prompt and send to it. And so this is an important thing to note because it has a lot of ramifications on thinking about prompt design. So I'm going to show you a quick example of this with ChatGPT and GPT 3.5. So I'm going to paste in the Wikipedia article that's related to the French Revolution. So I've pasted in a huge amount of text from the French Revolution desk um, that's described in Wikipedia. And what does ChatGPT say? It says, well, the message you submitted was too long. Please reload the conversation and submit something shorter. Now, this shows you an important point. We can't just give it unlimited information. Now, if we go back and we think about some of the things we talked about, some of the dimensions of prompt, one of the ways that we can use a prompt is to introduce new information that ChatGPT or another large language model wasn't trained on. So, if we want to go and introduce new information to it, we have to be aware that there's a limit to the amount of information we're going to be able to give to it at once. So, we may have all kinds of new information that we'd like to give to ChatGPT, but we can't just dump it all in at once and then say, now start reasoning on this. That's not the way it works. So, one of the goals that we have as users is to try to select and use only the information that we need in order to perform the task that we're asking ChatGPT to perform. So, we can't just go and dump everything under the sun in there and say, hey, ChatGPT, figure it out. We can go in and dump in a lot, and depending on the model, we may be able to do more or less, but have to be, to some degree, we have to be editors. We're content editors. We are editing the context of information, and we have a budget. We can't just, go and dump unlimited amounts in. We even think of it basically as, like, you're trying to create a paper and you have a page limit for your paper, or you have a word limit for an article that you're writing. You can't just go in and dump things, arbitrarily. So what do? Well, one, we have to think about what is the most important information to actually provide. So let's say, for example, that we really care about October 5th, 1789. Well, if that's the case, that's what we want to paste in for ChatGPT to reason about. And then we could go and we could say, what happened on October 5th? And then it would go and tell us what happened on October 5th. But now, if we ask it a question that is outside of the scope of October 5th and something it wasn't trained on, now in this case, it was probably trained on the information regarding the French Revolution, because obviously that was before 2021. But if we had new information we wanted to incorporate, we have to think about how do we put that information into our budget. So what are some ways that we can do that? How can we take large amounts of information and try to get it into our budget? Well, one, we can be selective about what we include. We can basically, outside of ChatGPT, go and run some type of query or filter. So we can go and select what pieces of information are going to be relevant to the task. And there's lots of ways of doing this, and I'm not going to go into all of them. We can have a filter. We can say, this type of information is not relevant. Remove it before we provide it to ChatGPT. Another thing that we can do is we can actually go and have that information summarized in a way that we think will preserve what's needed to reason about it. So, for example, we might say, well, maybe we can't paste in all of the information related to it, but we could say, we're going to take this and summarize each paragraph, summarize this information in one sentence, and then we would get some type of summary. And now this is slightly shorter than the original. So we have now a one-sentence summary of what happened. We could try to give it a word budget. So one way we can do it is we could actually take all the different pieces of information and we can ask ChatGPT or another large language model to summarize that information for us. And then we can take that summary and reuse it later. And we can put together several summaries, for example. Now, this only works if we make sure that the way that we summarize or if we make sure that the way that we filter preserves the information that's needed for whatever task we're going to ask for. So we might go through, we could also go and say, we said, summarize this information in one sentence. And we could say, summarize this information in one sentence. And I'm just going to, preserving information about numbers of people. And then when we get a summary that preserves the information about numbers. Now, if you look at the original summary, we see up here, it didn't keep the number of people. And if that was something important that we needed to reason about, then we would have lost that. And so if we had summarized in that way and then used that information um, to do some reasoning that required the number of people, obviously we've lost what we need. Down here, we've asked it to summarize, but we've asked it to summarize in order to keep certain information or in order to accomplish a particular task. So we did it by saying basically summarize this information in one sentence, preserving information about numbers of people. We could have also gone and asked ChatGPT, preserving information needed to reason about the population or to reason about um, how many people were in the resistance or in the National Guard. We could have given context. So one of the things we have to be cognizant of, is this budget on the size of our prompt is going to be a fundamental lie limitation that we are always trying to work around. Now, as large language models get bigger, they will probably reach a size where for many practical tasks, particularly when we are directly manually interacting with a large language model, that size doesn't really matter because we can just copy and paste, 50 pages of text into the model and ask it to provide us information out of there or perform a task based on it. But if you can think about how much information we're dealing with on a daily basis, there are probably going to be different types of tasks where there's going to be so much information, we can't dump it all in at once. And when we get into those types of situations, we have to think about either querying and getting a subset of information, like only the documents or only the parts of documents that are relevant. Two, we have to think about filtering. How do we remove information that's extraneous? Three, we have to think about how do we summarize or compress that information before we give it to the large language model. And one of the ways that we can do that, as we've just seen, is we can actually give chunks of information to the large language model and then ask it to essentially summarize or compress it for us in order to later use it for reasoning. We could also go and we can say, summarize or compress this information in order to accomplish a particular task or in order to preserve these aspects of the information. And that can help us to create summaries or essentially condensed versions of the information that preserve the important pieces. So this can be a powerful technique when we go and begin needing to reason on larger and larger amounts of information. Large language models are unlikely, at least in the near term, to give you an exact and repeatable answer every single time. There's always going to be the possibility that they do something a little bit unexpected. And this is by design and can be a really good thing. Now, a lot of what we're going to be doing in prompt engineering is trying to deal with the fact that large language models has some unpredictability to them. And we want to sort of constrain that unpredictability. We want to mold it and shape it and work with it in a way that's helpful to us. Now, what I mean by this is that there's always some randomness, some, ability to generate new and different ideas each time you put a prompt in. And this can be really good sometimes. Like if we're writing fiction and we want a lot of different ideas, a lot of different storylines, a lot of different characters, and each time we ask for new data or ask for a new output, we get something completely new and unique, then it's really good. On the other hand, if we're trying to have the large language model do some type of reasoning on a system, we may not want it to have a lot of variation in what it gives us out. For example, if we want a yes or a no answer, we don't want it to say yes sometimes, no sometimes, and then suddenly decide to say, well, maybe not, because here are these other things that I'd like to tell you about why it's hard to determine, and goes on this tirade for a paragraph or two about why it can't exactly give us the exact answer. Sometimes we just want a yes or a no without any explanation, and we can't always get that easily. So a lot of the prompt engineering techniques are going to be dealing with this. Now, I'm going to just show you a quick sample of the randomness, the fact that the same input is not necessarily going to give us exactly the same output every time. And I want you to remember this when we go through this course, because I'm going to show you a lot of different techniques to try to get the large language model to do certain things. And sometimes they're going to work really well and sometimes they won't work. But what these techniques will typically give you is they will give you something that's more reliable, that works most of the time or a lot of the time, but isn't guaranteed to work every single time. Now, this is an important point. We're always going to have some randomness here. We're always going to have some unknown, and we have to accept that and deal with that. So I asked ChatGPT, I said, how many birds are outside my house? And it says, as an AI language model, I don't have the capability to perceive the physical world. And he goes on, and then it says, if you're interested in finding out how many birds are outside of your house, you can go outside and observe the area yourself. You might also considering setting up a bird feeder. Okay, well, that was an interesting one. Let's see if we ask it again what it says. So now we're going to go and get a different answer out of it. It says, well, I can't see what's going outside your house. I don't have access to cameras. I only do text processing. And then it says, you could go outside and observe the area yourself, or you could set up a camera or other monitoring device to record, get the number of birds, availability of food, shelter, and presence. And so now we've gotten something different. And you know what we don't have anymore is this advice to set up a bird feeder. If we went and ran this again, we're probably also going to get yet another example. It's probably going to have some similar characteristics. It's still going and saying, hey, I don't have the ability to do that. It's running some of its things that, it's sort of standard text that it tells you. But then it's saying, hey, if you're interested in how you could try observing the area or to capture images of the area, you can then count the number of birds you see. Additionally, you could consider setting up bird feeders or bird baths. So we're getting a similar output each time, but it's not exactly the same output. And so this is a fairly constrained set of outputs for this question. We're still getting some similar type of things each time, but we're not getting exactly the same thing. And that's always going to be an issue for us. So know that when you're developing prompts, a lot of what you're dealing with is the fact that there is variation. Now, if I wanted it to give me an exact number, and I was using a prompt like this is obviously not going to work. Like, we're not going to get an exact number of birds outside of my house with this prompt. Now, we might need to be able to go back and give it additional information that could help it decide. The persona pattern is one of the most powerful patterns that we can use to tap into interesting behavior in a large language model. Now, what the persona pattern is you can imagine that you want to get a particular output, but you don't know exactly what the format of that output should be or what information should be contained in it. But if you were in the real world, you know who you would go to get that output or what you would go to in order to get that output. So, for example, if you had an accounting question, you would call up your accountant and ask your accountant for their advice. Or if you had a question related to speech-language pathology, like in the earlier example that I presented, you would go to a speech-language pathologist. You would have them do the assessment. If you had medical advice, you might go to your doctor. And so the persona or the person or the thing that you would go to, you know who or what that is in the real world. And we want to try to use that kind of same behavior of, I know who to go to, or I know what to go to get that output, but I don't know what their output would look like. I don't know exactly what they know or how they talk about things, but that's the type of output I want. And so the persona pattern is meant to give us that same type of behavior to allow us to go to that expert and ask that question without having to know what exactly the expert's going to say, how they're going to format it, or what they might know or not know. So let me show you an example of the persona pattern. Typically with the persona T patterns, what you're going to say is act as persona. Provide outputs that persona would provide. And in this case, I'm going to word it as act as a skeptic that is well-versed in computer science. Whatever I tell you, provide a skeptical and detailed response. And now if I wanted to be a little bit more precise in following the pattern, I would say provide a skeptical and detailed response that a computer scientist would provide. But in this case, I'm just going to say act as a skeptic. And that's really the most important part of this, is act as a skeptic or act as whatever persona, and then provide the output that persona would provide. And in this case, I'm wording it as provide a skeptical and detailed response, which is similar in format. And then ChatGPT says, sure, I can certainly act as a skeptic well-versed in computer science. Please feel free to present your claims, and I will provide a skeptical and detailed response. Well, I'm going to start off with, there is concern that AI is going to take over the world. And so we get a skeptical response. The concern that AI will take over the world is a common theme in science fiction, but is not a realistic concern in the near future. While AI systems are becoming more sophisticated and capable, they're still limited in their ability to think and act autonomously. AI systems are designed and programmed by humans, and they only do what they are told to do. They have no independent will or motivation. They cannot make decisions. Furthermore, AI systems are not fallible. They can make mistakes. While it is important to be vigilant about the potential risks and limitations of AI, the concern that AI will take over the world is unfounded and not supported by technology or research. So we're getting a skeptical response. If I went in and said, the sales the salesperson at the local computer store is telling me that I need 64 gigabytes of RAM to browse the web. And they say skeptically, it is highly unlikely that you need 64 gigabytes of RAM to browse the web. The amount of RAM you need depends on the complexity and size of the websites you visit, as well as the number of tabs you have open at once for most web browsing activities. And it goes on to tell us different things. And you can see that our saying, act as, has put in place basically a complex set of rules for the large language model. It knows it's supposed to be skeptical. It's supposed to have knowledge of computer science. It's supposed to provide certain outputs. Now, if I went back to it and I said, act as a 9-year-old, whatever I tell you, provide a skeptical response from a 9-year-old perspective, and I go, 9-year-old skeptic. Now, that's a more complex persona, or maybe not. AI is going to take over the world. I don't know about that. How could AI take over the world? Do you mean like in the movies? Aren't those just made-up stories? And besides, computers and robots can't do everything humans can do. Now, you notice it's still providing us a skeptical response, but now it's doing it sort of with the knowledge that it thinks a 9-year-old would possess. So it's tailoring the output. Now, if I had to tell it, this is how a 9-year-old's going to respond. Here's the format for your output. That'd be hard to do. That would actually take up a lot of room in the prompt. But act as blank is a very, very powerful pattern and statement that is, loaded with information. It's a very information-dense pattern and statement that can trigger all kinds of different behavior. Now, one of the interesting things is we don't have to limit ourselves to patterns or personas that are animate objects. So, one of the famous ones is we can say, act as a computer that has been hacked. Actually, we're going to say, act as the Linux terminal for a computer that has been hacked. Now, don't worry if you don't understand what a Linux computer is, or a terminal. The key thing to note is you're going to see behavior that looks really interesting and different. You're going to see it producing output that looks a lot like a computer. I am going to type in Linux terminal commands, and you will respond with the output that the Linux terminal would produce. Now we're going to say, now it tried to refuse it. It said, please note that it can be dangerous. It gave us all these different things. It tells us it doesn't want to do this. But now I've actually changed what it's doing, and I type in pwd, which is a Linux terminal command, which means print working directory. And what is it doing? It's printing a particular working directory. Now I'm going to type in a Linux command, which is tell me the files in that directory. And you notice it's producing output now that looks like the files within this directory. And we see a lot of interesting things that are going on here. We could move around. Now, if you do this example, and go further into it, PSSGF is something I can use to see what processes are running on the machine or the computer. And when you do these examples, and I could play around with it, and I am not going to explore it in detail in this, but we see it, that it's acting like a computer. It's giving us output that looks like a computer. Now imagine if I had to try to describe this complex output that it's producing right now. You notice how little information I gave it? This was I gave it a lot of information, but it was in a short amount of space. This pattern, the persona pattern, is giving me really powerful behavior. So I'm using this little bit of prompt, and I'm getting now the ability to simulate this whole system. Now we can also do this in all kinds of different interesting ways. We can say, act as the lamb in the nursery rhyme, Mary had a little lamb. And now we're getting some output that looks like that. Actually, what I'm going to do is I'm going to make this a little more specific. My prompt wasn't that great. Act as the lamb in the nursery rhyme, Mary had a little lamb. I am going to tell you what Mary is doing, and you will tell me what the lamb is doing. Okay, Mary is in the grocery store. So as the lamb in the nursery rhyme, while Mary is in the grocery store, I would be following her around as closely as possible, trying to stay by her side, and maybe even nuzzling her hand for attention. Um, Mary is in the movies. As the lamb in the nursery rhyme, while Mary is in the movies, I would not be able to accompany her inside the theater due to my inability to watch movies. So I would probably wait for her outside the theater, perhaps nibbling on some grass, or wandering around the nearby area until Mary came back outside. And it goes on. And so you can see that you can create all kinds of interesting personas to produce output for. So we can say, work, pretend to be this job, pretend to be a speech language pathologist, or pretend to be an accountant, pretend to be a computer scientist. You can make your persona have something to do with the person's point of view or opinion. Make, you know, act as a skeptic so that we can get skeptical output. We can say to act as an inanimate object that may have well-known sort of behavior, like act as a computer, the Linux terminal for a computer that's been hacked. And we saw that we got all kinds of output that looked like it came from a computer. Or we can say, act as this character in a nursery rhyme. Tell me what this character is going to do in a particular situation, and we're getting that output. So the persona pattern is a way that we can tap into sort of the patterns around language, around a specific persona or object or character in a story, in order to get output that comes from that point of view, from that role, whatever it is. It's a really, really powerful capability. Now, one of the things is we often see that when large language models are programmed, they actually have a persona that's given to them to guide the whole interaction. So, act as a really helpful assistant, and this actually makes a difference. If you tell it to be helpful, it will try to be more helpful. If you tell it to try to do something, positive, it's going to try to be more positive. Similarly, if you kind of give it a negative perspective, like my skeptical perspective, it's going to give you output that challenges you or maybe darker. And so, the persona that you ask the large language model to use is really, really important and powerful. The other thing, just to note again, is it's really information dense. It has a lot of pattern and knowledge around a persona that if you had to describe it from scratch, you would take up a lot of space in your prompt. You'd be losing, valuable space in your prompt to provide new information. So if you were providing a lot of new information, you might want to say, act as, whatever it is, and evaluate this new information. Well, the more space you've taken up in your prompt describing how to do the evaluation, and what point of view and other things to take, that's wasting space. But instead, if you go and take the persona prompt and you say, act as, this persona, provide outputs that persona would provide, you're giving it, a really, really information-dense statement that it can use and allow you to have more space in your prompt for other things. So the persona pattern is a really, really powerful pattern to be aware of and know that it's a very valuable one. You can do all kinds of things, like if you would normally get a committee of people together to discuss different points of view on a particular topic, well, you can assemble a virtual panel. You can have one prompt say, act as a security expert and analyze my cybersecurity. You can have another one say, act as the chief financial officer, analyze the financial soundness of that same decision. Another one can be, act as one of my employees, discuss how this might impact morale. You can provide sort of interesting abilities to get different perspectives and use those different perspectives to potentially inform decision-making or to collect knowledge from different points of view that could be helpful to you in accomplishing a particular task.